So we're going to look at confidence intervals when the standard deviation is unknown. So last week we saw that a 1 minus alpha level confidence interval for the population mean was given by this expression. So we have our sample mean, and then it's plus or minus this the error, which depends on this z critical value, which we looked up in the table. So as a quick example, suppose we know what sigma is and we found x bar based on our sample, and the sample size was 9. So if we want a 95% confidence interval, we look up in the table and find z equal 1.96, and we find our error, and so here's our 95% confidence interval. It's this, 12.4 to 17.6. Okay, so now we're going to assume that sigma is not known. So we're going to assume the same example, but assume that we don't know sigma. Well, what we just do is replace the standard deviation with the sample standard deviation, but then we also have to replace z with a different value. So it's a t critical value, which is found from the t distribution. And then there's also the degrees of freedom we have to consider, and that's always just n minus 1. So to find that value of t, we're going to look in Appendix A. So it's a different table. Again, the degrees of freedom is always going to be n minus 1, and we're going to look for area in two tails. Well, that's because our confidence interval setup, when we draw our sketch, we always have alpha as the area in both tails. Okay, so this is the HTML version of our book online, which you can find in my stat lab. And so we have to look, we want the area in two tails to be 0.05, but we also have the degrees of freedom. So we look under 8 degrees of freedom because 9 minus 1 is 8. And we find this value 2.306. So all we have to do is replace z sub alpha with, or z sub alpha over 2 with this value t in our formula. Okay, so we're going to take the same example, but we're going to suppose that sigma is not known. And we'll suppose that we have the same standard deviation, but it was found from our sample. So this is not the population standard deviation. We don't know the population standard deviation, but we found it to be 4 based on our sample. And suppose we found the same sample mean. So we looked up that value in the table for t. This is our t value, and this is our s over radical n, and we get this for our error. So we found our 95% confidence interval to be this, and this is our confidence interval. So notice that it's larger. Okay, so when sigma was known, we got this as a confidence interval, and when it was unknown, we got this as a confidence interval for the same level of confidence. And does that make sense, to get a larger confidence interval? Well, if you think about it, if you don't know sigma, it's more uncertainty, so there should be a larger error. So the larger error gives us a larger confidence interval. This is very easy to do using StatCrunch or Excel, so we'll try that next. In StatCrunch, we're going to go over to Stat, and notice we have selection for Z-stats or T-stats. Well, these are both based on whether you're going to use the T distribution or the Z distribution. We know the Z distribution, we'll use that when sigma is known. And we're going to select one sample, and we're just entering the summary data. Now, if we had the raw data, we could just use StatCrunch to select data. But we have the summary data. So our sample mean was 15, the standard deviation was 4, and the sample size was 9. And we want a confidence interval, so we'll select that, and we can enter whatever the level is. So we had 95, and there we go. So we get the lower and the upper limit, and we get the error, and that's that. Pretty straightforward. Now if we don't know sigma, we're going to use the t-stats, again one sample with summary. So now you're going to enter the sample standard deviation. Before we entered the standard deviation. So this is, let's see, the sample mean was the same. Sample was, the standard deviation was that. Sample size was 9. Again, confidence level. And we get this, and you can see this corresponds with our results before. So to find confidence intervals for the population mean, we either know sigma, in which case we look in the z table, we use the z distribution, or if we don't know sigma, we use the t distribution. Either of these can be done using technology, StatCrunch or Excel.